This is a review for Part 1 of Chapter 9. We've studied the concepts in the field of experimental design. When researchers wish to show how a variable with several categories has an effect on a quantitative variable, we look to analysis of variance. In the example studied today, organizational psychologists studied the effects of color in manufacturing workers' environments. They randomly assigned 8 workers to 4 different colored rooms to work in and recorded their pulse rates. They controlled the room temperature and the tasks to be done. The workers were unaware of the color variations, and the data analyst had no prior knowledge of the colors applied. This is how ANOVA works. It makes pairwise comparisons of more than 2 groups of means. So here's the data. We have 8 workers assigned to the blue room, then another 8 randomly assigned to the white, 8 in the yellow, 8 in the orange. Therefore, we can compare the mean of the blue to the mean of white, blue to yellow, blue to orange, white to yellow, white to orange, and yellow to orange. That means there's 6 possible pairs to be compared. What's behind the formulas? ANOVA controls for the variation within the groups and then measures the variation between the groups. So the circles represent that each group has variation inside of it. It controls that. Then the arrows represent that it's measuring the difference between blue and white, blue and yellow, and so on. There are 2 ways we can gain data: through observational methods or experiments. Data is observational when we simply record what's happening. We haven't set up any certain design. The samples may be retrospective from the past or prospective, which would be current. In the book, we called the data past if it was from a year or longer, if it's current within this year. Data could also come from secondary sources, like the Bureau of Labor and Statistics. Also, groups may not have the same number of samples in them. So if I'd only had 7 workers in the blue room, 8 in the white, and 6 in the yellow, it would be unbalanced. Experimental data, though, should be balanced. We would look for 2 particular words to know it's experimental: the word random and control. So in this case, we randomly assigned the workers to the different colored rooms, and then we controlled the experiment by having them all do the same task, and the room temperatures were the same. But also, the analysts decided that in white rooms, that would be the control group. That's what their pulse rate would be normally. Designing the experiment requires us to define several different terms. The experiment itself is recording the pulse rates based on room color. The variable manipulated to see if it affects the outcome would be the factor. Here, that's the room color. The levels are the labels. So the categories for that factor were blue, white, yellow, and orange. The response variable is what we measure or record. So in this case, that would be average pulse rate. These studies can be double-blind or single-blind if we withhold information from both the subjects and the analyst. It's double-blind. Single would mean we withheld information from just one group. So there are three types of designs. In part one, we've studied completely randomized designs that have only one factor. Part two, we'll look at randomized blocks with two factors and no replication. And part three will cover factorial designs. For a completely randomized design, we set the means equal to each other. So the mean pulse rate for the blue room equals the mean pulse rate in the white, and so on. HA will say at least two means differ. We go to the output and find our test statistic under analysis of variance. That's the F ratio of 107.66. Its p-value is 0.0001. That's less than 0.05, so our conclusion is we're 95% confident at least two mean pulse rates differ based on room color. Now we need to determine which of those means differ. You can look at the Tukey-Kramer plot, and here if the circles overlap, the groups are not different. None of these circles are truly overlapping, so then you can look at the distance they are from each other on the y-axis. The orange group had the highest pulse rate. The blue group had the lowest. The white, which was our control group, is in the center. You can also look at the connecting letters report. Any groups that have the same letter would not have any difference in their means. Each one of these colors had a different letter associated with it, so all four groups are different. Then you can look at their average pulse rates under the mean column. Again, we see orange is the highest and blue is the lowest.